All right, guys, we have our missing lesson from Unit 4, which is on inverses. So hopefully this ties a few things together. There was a notice and wonder. I'm going to skip it just for the sake of the video, but basically these two, the blue and the green, are inverses of each other, which we'll come to figure out later. So if you want to visit this slide again, you'll see why. But the inverse notation is called F inverse of x. Now, usually when you see a negative exponent, you think that moves things to the denominator. It doesn't in this case. It's the same notation. It is an exponent of -1, but it's not. There's no math behind that. Just it's read as inverse. So you see it in trig a little bit too, but we're going to read this as F inverse of x, if you kind of say that in your head as you see these notations. But it doesn't create a fraction or anything like that. So that's our notation for inverses. So defining inverses, just a definition for you guys if you want it on your notes. Two functions are going to be inverses. So f of x and f inverse of x, right? They're inverses if, when you do compositions, which we did do in Unit 3 actually, if you do f of f inverse of x, those two things will basically undo each other and you'll just get x by itself. And then f inverse of f of x will undo each other and just get x, which we're going to do in a little bit. So if that sounds confusing, don't worry. So finding an inverse of a graph. Let's say that our original graph is 2x plus 1, right? So y equals 2x plus 1. Well, if you want to find an inverse of a graph, you simply, instead of doing f of x, you're going to do f of y, which sounds weird, but basically instead of an x being there, a y is there. So it's going to flip-flop your y and your x, and that's basically, and then you just resolve it for the new x. And if you want to graph it, make a table and graph. But if we're doing f of y, right, I would just rewrite f of x as y. That way you can just use one letter instead of two letters. But at this point, right, we're going to do f of y, so it's going to be x equals 2y plus 1. And that right there, ladies and gentlemen, is the inverse. Now, usually with equations, you try and get the new y by itself. So that's what we're going to do. So I'm going to subtract 1, and then I'm going to divide by 2, so that I'm going to get x minus 1 over 2 equals, and instead of saying y, I'm going to actually use my f inverse of x, and that would be my answer. And the reason why I want to replace y with that is just to denote that we are now talking about our function's inverse. So that is an important step. You do want to get rid of the y and replace it with f inverse of x. But that's it. So you can see that if we name x minus 1 over 2. So these two things are inverses of each other. Now, if you wanted to graph it, right, y equals 2x plus 1, we're probably pretty good at doing that. If you just think about some points, right, if I plug in 0, I get 1. If I plug in 1, I get 3. If I plug in, I don't know, -2, I'll get 2 times -2 plus 1 would be -3. If I plug in -1, I get -1. Right, so just plotting some random points here, although you don't really need to plot those, but I'll show you why I did that. So I got 1, 3. I got -2, -3, -1, -1. So, that's my graph of the original. Now, if I wanted to graph the inverse, well, we already figured out what the inverse was. So I'm going to do this one in green. But like, if I just want to plug in some points for this one, I could plug in like 1, and that would give me 0, because my numerator would be 0. I could plug in 3, so 3 minus 1 would be 2. 2 over 2 is 1. I could plug in -3. -3 minus 1 is -4 over 2 is -2. I could plug in -1, and I would get -2 on top divided by -1. And if you notice these coordinates, how do they relate to these coordinates? They are just the opposites, like they are reversed coordinates. Shouldn't say opposites. They are reverse coordinates, which makes sense because how did we even find the inverse? Well, we flip-flopped x and y, so it should make sense that the inverse's coordinates are simply flip-flopped x's and y's. So I have, instead of 0, 1, I have 1, 0. Instead of 1, 3, I have 3, 1. Instead of -2, -3, I have -3, -2. I still actually have -1, -1, because that's the same thing reversed, but that's it. And so that would be my graph in the green, which is the inverse of the graph in the black. And if you notice, they actually are reflections of each other over a special line, which is y equals x. So if I just drew a line with a slope of 1 and a y-intercept of 0, you can see if I folded the paper along that red line, the black one would turn into the green one and then vice versa. So all inverses are going to be reflections over the line y equals x. Which again kind of makes sense. If you flip-flop y and x, then y does equal x, like with the inverse. One's y is the other one's x, so that's why it reflects over that line.